Hello and welcome back. Video lesson number 2. I'm going to be going over sig figs as our last review and then introducing accuracy and precision and percent error. So let me share my screen and we will start our lesson. So objectives to review questions that you have to date. While I'm with you in class, I'll ask if you have any questions. Precision and accuracy and percent error. Here are some of the tricky things from sig figs. Notice this number with 2 zeros at the end. It would only have 3 sig figs since those are trailing zeros. But what if in recording that number, I want it to have 5 or 4 sig figs? I pointed out yesterday that the decimal point and the bar over the zero are 2 more ways to indicate sig figs. Of course, scientific notation always clears up any misunderstanding about sig figs. I'll show you on the board that this was a very common mistake on the summer assignment. To write the number 6,000 to 1, 2, 3, or 4 sig figs means you still have to keep the magnitude of the number 6,000. You can't just drop to the number 6 for one sig fig. So that was a little tricky, and I'll show you more about that on the board. This was probably the hardest problem on the summer assignment, and it's because I'm asking you to do a calculation here. Look at the red star. This calculation is difficult because you have 2 sig fig rules. One sig fig rule is to subtract, and then you have to divide, which is a different sig fig rule. My clue, my suggestion to you is to always do the subtraction first and write it down to correct sig figs. Then do the division. You see, if you didn't notice, the numerator dropped down to 1 sig fig upon subtracting, you would not get the correct answer for sig figs with the number 1 and only 1. I keep highlighting this with the yellow oval on the homework packet, in the homework packet, and the answers in the homework sheet. Notice that yellow oval. I'll tell you, it is the most common mistake on my quizzes and tests. Just do it. Write down the subtraction of the numerator before you go through and divide. This will be the problem with percent error also. I point out that sometimes I do a side calculation. This will be more common as the week progresses. I draw a line and I do a little calculation over here such that I can see the answer has 1 sig fig. But that's not a necessary part of getting to the overall answer to this problem. It's not a necessary part always to show, but I like to show it because it confirms my accuracy. Now here I have on page 7 in the class packet, lots of sig figs for you to practice. I'm going to recommend that right now you pause this video and you go through and quickly write down the number of sig figs in all these numbers. When you're done doing that, go to Schoology and check your answers. If there are any of those sig fig answers that you've gotten wrong, you need to find the problem. We're done with sig figs as of today, although every answer that you give me in chemistry will have sig figs as one component, 1 point for sig figs. After you do 1 through 12, pause again and do 13 to 18. See if you can do those calculations. Actually, you probably won't be able to do 18 until I teach the next component. Check your answers. If you're making a mistake, to know is to correct it. This too is practice that you should confirm doing correctly. On page 7 in the class packet, here are some more instruments for you to write down the measurement in correct sig figs and check it in Schoology. Remember, you and I will not disagree on the certain numbers in a significant figure, but we can have different numbers when it comes to the digit that is uncertain. One more set of practice. On the class packet on page 8, the trouble with the zeros. Zeros are the most confounding. So here I have 19 problems. Pause the video, write all the sig figs here down the end, and check them on Schoology. Are you getting these right? If you are, you'll do fine on the quiz, you'll do fine on this part of the test. On the class packet, page 5, I have some interesting measurements for you to make. These too are in Schoology posted with answers, but we should practice them. Notice this first ruler goes from 0 to 10. That's the only line I have, a 0 and a 10. I have to guess every number between 0 and 10. That means that number is my uncertain number. So if I were to guess a number for the length of this gray bar, I would probably guess 5. Now, if you guessed 4 or guessed 6, you would be correct also. But it's one sig fig because that particular number is the uncertain number. Now, in this ruler, notice I have marks for 1 centimeter also. So now I have the number 1, 2, 3, 4 indicated with certainty. But the number between 4 and 5, I'm guessing. So here I might guess 4.3. I would write down 2 sig figs, 4.3 centimeters, with the 4 being certain and the 3 being my guessed or my uncertain number. The measurement for number 2 would have 2 sig figs. We do not disagree on the number 4, but we can disagree on the number 3. Maybe you put 2 or 4, and that's all right. I would like you to try some more of these, page 5 in the class packet, and see how you're doing. Pause and practice yourself. If we were together in the class, we would be doing these problems together, and you'd be talking to the people next to you. But unfortunately, we're going to make the best of learning chemistry by you doing this now. Pause the video. Check your answers. Here is a new topic that is well described in your book, and it's well described on anything you would check on the internet. You can confirm your understanding of this by Googling it on the internet, having this clearly distinguished. Accuracy and precision in the English language are oftentimes used synonymously, but in science these words have very different and special meanings. Accuracy has to do with being very close to the correct answer. Like if this were a bullseye, those 4 arrows being shot at the bullseye are accurate because they're close to being correct. That's accuracy. Precision, however, is how close all of your data is to each other. So if I'm shooting arrows at a bullseye, you see that all of these arrows are close to each other. It looks like I'm shooting my arrows consistently. This is very precise in this example, but not accurate. So you see the difference between accurate and precise. This is accurate and precise. The second bullseye is not accurate when you average those 4, but it is precise. When you go down to number 3, it's always interesting because those 4 arrows, or we might call them 4 pieces of data in the lab, are not close to each other. There's a range of scatter in that data. But by the time you average them, the average of those four would be very close to being correct. So they are accurate in their averaging, being close to the answer, but not precise. Example 4 here is neither accurate nor precise. This concept will be very important when we start talking about lab data and writing conclusions in IB lab reports. So clarify this in your head sooner than later. Percent error is the most commonly made mistake on this chapter. So first, there's a definition that is something you've got to do. The observed value is sometimes called the experimental value when you're doing an experiment. The true value is sometimes called the literature value. When you do an experiment, you're going to be able to calculate your experimental value. I oftentimes call it observed. But you're going to look up in some authoritative book what the true value is, true in quotes. That's called the literature value, but I'll keep calling it the true value. You must write down the equation for percent error before you solve for any percent error. This will be a formatting requirement to doing math in chemistry. First, you write down the equation, then you substitute in the numbers, then you show your answer, only expressed to correct sig-figs with unit. So here I have the equation for percent error. Observed minus true over true times 100. The next requirement is to substitute in the numbers times 100. Now this yellow oval is where I have made the point of showing you the subtraction of the top two numbers. You'll see if you didn't write that down and you just plug these numbers into your calculator, you would miss how many sig-figs you should write down for the answer. Only by writing down the subtraction of the top numbers will you see, oh my goodness, those two subtracted values of observed minus true reduce the sig-figs down to 3 for the top of this fraction. So when you actually finish the problem, you have only 3 sig-figs in your answer. The answer expressed to sig-figs with unit. Even though your calculator will say this for the answer, do not write it down. Only write the answer down to correct sig-figs with unit. As I said, this is the most commonly made mistake on the test. So I want you to pause now and try this problem. My way of saying it is observed minus true divided by true times 100. So here are your two values. You try it. You don't have this in your class packet. You're going to just practice this on a piece of paper. See what value you get, and then read this bottom part on this slide. Pause the video, come back with your answer. So, percent error is something that you'll do for your homework sheet tonight, and you'll know whether you've got this concept or not. I have more rulers in your class packet, but I would recommend you take the time and write down the measurements of the gray bars. Check your answers on Schoology. Remember, I don't collect your class packet, but the more practice you give yourself, the more prepared you'll be to handle the assessment, which is always a little more stressful than just doing your homework. The last topic here is on page 16 in your class packet, and you'll need to refer to your textbook. In your textbook, it talks about base units and derived units. I personally find this a fascinating topic. In all known things of the universe, science has described 7 base units. That means those are the units that are pure and can be used in combination then to describe everything. The base units are those simplest single units that we use in all of science. I'd like you to fill out this chart so that you can start to appreciate the time and length and the more are very important base units. Can you imagine? Out of everything in this unit, 7 base units can be used individually or in combination to describe every mathematical computation or measurement. That's a mystical experience for me to think about, and I like thinking about science that way. You also have this chart that I want you to fill out that talks about derived units. A derived unit is where you take at least 2 or more base units, the 7 base units, and put them together. For example, density is mass, which is a base unit, divided by volume. Volume is not a base unit because you had to use 3 base units, length, width, and height, to determine volume. So density is an example of a derived quantity or unit. I want you to know all 7, actually if I go back, you need to know the top 5 base units. And then you need to recognize, not necessarily know these units, but you need to recognize when a unit is not a base unit, therefore derived. Read up on this a little bit and you'll understand. Ask if you have questions. So this is the end of lesson 2. The summary is for you to number 1, discern the difference between accuracy and precision. Calculate percent error with the correct formatting and the correct answer, only written to correct sig figs with units. Formatting means you write down the equation, you substitute in the numbers, and you do the work in your calculator except writing down that yellow oval part to express the answer correctly. Sig figs should be well understood now with these 3 expectations. Any number I give you, you can turn into sig figs. You can manipulate sig figs in calculations and read sig figs off of lab equipment. On Wednesday, we're going to be starting the next big topic in Chapter 2, which is dimensional analysis, sometimes called factor label in your textbook. That is usually a brand new idea to you, and it is the mathematical technique of how we'll do all of our mathematics and chemistry. When you go to college, dimensional analysis is probably the most valuable skill you'll take from IB chemistry. It's oftentimes a dense topic. We have to practice dimensional analysis for several days. Therefore, I recommend that you be prepared to start this new topic on Wednesday. Be done with sig figs. We'll also be starting a new lab on Friday. So both of those new topics, dimensional analysis and the new lab, will demand your attention. So tonight you have a video lesson homework check on videos 1 and 2. It is found in Schoology, and I wish you luck. Goodbye. I'll see you in class today, and I hope you're ready for the homework check. Goodbye.